We have a wonderful set of speakers on a fantastic topic. I welcome Ran, who is the CTO of Epsilon. He was actually the first confirmed speaker for this conference. We confirmed Ran, and he confirmed during Create Frontend 2 months ago. And here we are. 2 months have passed in like 1 second. I'm delighted to have Ran come back to the Create series and talk more about observability. And we're also super delighted to have Jennifer join us. Jennifer is a senior cloud advocate at Microsoft, and she wrote a lot of books, and she is an incredible expert on the topic of DevOps and observability. So I'll leave it with the two of you to talk more about observability and serverless.
Awesome. Thank you so much, Simona. Really appreciate the introduction. So today we want to talk about observability and serverless. It's one of the key components of an operable production environment. But before we really get into discussing together, it kind of helps us to talk about what we mean by observability. So how about you start, Ron?
Yes, definitely. And thank you. And by the way, I do want to show off my shirt, the serverless ASCII function. Super cool. I got it a while ago, but I just
fantastic.
Yeah. So we'll have three things that we want to kick it off with, talking generally about monitoring, about observability, and about distributed tracing, and then we'll kick it off into the internals of this discussion. But I do want to set, the first kind of things off the ground. And what is monitoring is a question that probably can answer in a lot of ways. But for me, I think monitoring is to watch our system health. We got a system running in production. We want to make sure it is working, and monitoring is specifically the way to do it in this case. Now, usually when we're speaking about monitoring, we have some vital signs that we're looking at. Can be latency, traffic, errors, saturation. All of them are good. They will give us a good sign whether we got too many errors or what's the traffic right now, or whether our user is experiencing slow performance, which again tells us about our system health. And in most of these cases, we rely on some agent-based approach that, we're deploying an agent into a host, which, gathers all this kind of information. Then it's being visualized in another dashboard. Now, I think one of the problematic things when we're thinking between monitoring and observability is that usually when we're thinking about monitoring, these kind of agents just collect host metrical data like CPU, memory, network, disk, and things like that, which can be sometimes okay. But when we're speaking about observability, we want to have something more broader, something more complete. Now, when I'm speaking about observability, again, this is probably have lots of definitions and lots of ways to describe what's observability, but trying to summarize it up very quickly, it's about understanding applications, or if I'm putting the parentheses, truly understanding complex applications. Obviously, if our application is super simple, so we don't need that fancy thing.
Ron, it looks like you've muted yourself.
Sorry, am I okay again?
Yeah, you're okay now.
Perfect. Sorry, I might probably lost my AirPods. Sorry. So I'll review quickly what I've mentioned before. So we do have a more stricter definition for observability, at least what the people are saying, which concludes or includes three pillars: metrics, logging, and tracing. Now, I'm trying to sum it up in a simpler way because, metrics and logging are pretty straightforward. Tracing is also something that's been here for a while, but what actually these pillars gives us, and I try to summarize it up in a nice way. Metrics tells us what happened. For example, slower latency in our website, or number of 500 errors is increasingly high. Then the logs tells us why something bad happened. Like, we got a 500 error. Now we need to actually understand what happened in the code. And tracing, which it's not new, but it's relatively been adjusted towards distributed applications, tells us where the problem happened. Because in these scenarios, the problem doesn't necessarily happen on a single place. It's like the problem occurs in a certain place, but it has a chain of events that led to this problem. So traces or distributed traces really tells us the story or where something happened. Now, last piece is to understand about distributed tracing. Again, distributed tracing is not something new. And the simplest way to put it is look at the story on the right-hand side. It's just a story. It tells us how an event is moving from one service to another in our system. I could probably visualize it, with logs that will tell me 1, 2, 3 timelines and so on. But this is much simpler, way to put it about a story that moves from our client to the load balancer, often off service, billing, and another resource. So in other words, distributed tracing is a way to connect the dots between different services as the request is moving between one to another microservice. I would love to show quickly something about how all of these things can be leveraged into observability or distributed tracing, which becomes very much powerful. And I'm going to demonstrate it through Hexagon, through some of our environments, and it's going to be very much tailored for Azure function environment. So here we got a specific function. This is the Hexagon dashboard. We're looking at on a specific trace. We can see here that we got an Azure function, which is being triggered by an API gateway that listens to our website. And then we got another Cosmos DB that gets the request. Now, I didn't need to tell you all of this because it's pretty straightforward to see what are the chain of events and the consequences. This is, by the way, relatively simple. It's not very complex to understand what's going on, but think of what happens when I'm having 500 functions and not just Cosmos DB and multiple of integrations and triggers to my function. This is getting more and more complex. And being able to understand the flow, being able to see all of the details, the metadata, the context, the actual data, for example, what kind of headers are coming into my function, or exactly in my Cosmos DB, for example, which document am I altering, what operation am I doing, how long it takes. These are the things that allows me to gain observability, or the way I've mentioned it, really understand my system. And it can be either in this way or even in a timeline mode, which tells me, the sequence of events, which, by the way, again, in this case, it's relatively simple. This function only called the Cosmos DB, but it can get much more complex from these scenarios. Now, obviously,
you can just imagine if you had a bunch, you could see this, and it would be really great to see that timeline of events.
Yeah,
and how much,
exactly.
Yeah.
Exactly. In complex scenarios, it's become crucial, especially when you're talking about node applications where things are running asynchronously. You really need to understand, the consequences or the performance of events, the way we call it. And ultimately, I'm not forgetting about metrics. Metrics are important key to understand our system. Things that are pretty straightforward, like the amount of the request, the number of errors, and the type of errors, whether we're getting just an exception or 404 or 500, and then also the latency, which is important to understand because ultimately these three metrics are the things that our customers experience, and that's the thing that we should optimize in order to have a better business. So I think that's it, with the intro and the live demo. I think we're good to go for a discussion.
Awesome. So thank you so much for sharing. It's always so fascinating to me to see how different people think about these different terms, because I think a lot of why we have arguments is because we don't set the context of what we're talking about. So I'm going to share my feelings about monitoring observability. So coming from a background of so many years in operations and system administration and doing software engineering, it's like I feel like I've got this interesting feels about monitoring. So for me, monitoring is that process of measuring, collecting, storing, exploring, and visualizing the data from your infrastructure, which includes your hardware, your software, and the people processes, because people are critical to how your systems work. If you don't think about the people, you're going to have some really bad outages when people are super tired or burned out. So to me, monitoring helps you answer the when and why questions of your work, and it informs the business decisions that support creating sustainable environments. So instead of, it helps you understand, should I hire more people? Are my engineers overworked? I know a lot of people don't think about that, but to me, it's so crucial because if your people are tired, they're going to be making some terrible decisions. Then, when I think about observability, observability is a study of a specific property of a system. I don't think about it as in pillars because I think of that as those are the tools that can feed anything. That can help my monitoring, that can help my observability, but I want to be able to ask questions of my system. So I think about monitoring as these are the things I know about my system, and I'm going to monitor them. I know that these are the things I need to care about. I might be collecting other data. That doesn't say that but it's what I'm presenting and sharing. Then when I think about observing my system, am I able to ask any question I want? Am I able to just think of any random thing and debug something if needed, or explore it? It can be really interesting. But when it comes down to it, it doesn't matter if we agree on the exact definitions. What we're saying, though, is that we see there's a problem and we're going to solve it. And so, let's talk about what are those ways to solve it. So if I was a new engineer to this, like an engineer that was new to this topic, and I didn't know, what do I do? What do you think day one is for solving this problem?
That's a great question. And, many engineers face the fact that they're seeing observability, which becomes kind of a buzzword, and they want to do observability, but they don't really understand the implications or where to start and what to do. So I think that the first thing is even a step backwards. Before you want to do observability is to understand what is your current pain point. Is it long troubleshooting time? Is it, suffering from alert fatigue of too many errors that are coming up, but they're not very much, drilling down to the real problems? Or is it just observing the system in an essence of, understanding the service map and the complexity and the dependencies? So first step is just to understand what's the value that you need from observability. Once you have that question figured out, go ahead and read about it. Before diving into the water, you probably, open a manual, you read about it, you understand best experience, you discover the market, what are the possibilities in terms of open source solutions, off-the-shelf solutions, what coming out of the box, from the cloud vendor. So understand a bit the ecosystem. I'm not saying, write a thesis about observability, but at least spend a day or two in understanding the ecosystem. Once you got it out, it's pretty perfect. You know where you want to be, what's your problem, what you want to accomplish, and you have a ways to accomplish that. So just pick a way, whether it's, going with in-house implementation that you might prefer, or just with a third-party API that will come out of the box. It's really up to your decisions to do so. Now, the last thing about implementing observability across the organization, or in general, it's true for any kind of, adding a new solution or adapting a new way to do something in an organization. Do it step by step. Don't force anyone or everyone to do your kind of observability from day one, but try to adopt it organically, and also make sure that you're telling your decision makers and stakeholders, let them understand what is the pain point that it solves for you, for your team, for your department, how it can help you bring better software, deliver feature faster, reduce the time to resolve issues and things like that. This is important because don't try to work solo. You need your executives alliance, to be aligned with what you're trying to achieve. And once you'll say that, I'm pretty sure that everyone will be in the same line. That will give a green light to go with that, because that's super important for modern applications and modern businesses.
So I kind of think of it, it's good that you mentioned sort of, I think of that as like the DevOpsing, the executive stack, like communicating in the language that they want. Because often we try to throw, this is the problem. They want a single pane of glass for dashboards. Yeah. That's not going to help. That they might have a dashboard, but that's not going to help me in the trenches. And one of the things I think about is how you navigate convincing management that this is actually something that's important to do. And I kind of group environments into these three buckets. One is the bucket where nobody's aware of anything. They don't know what's going on or what solutions there are to solve the problems that they're having. They recognize there's a problem, but it's just everything is terrible. And then two, it's yeah, we know it's a problem. We know that's available, but you know what we have now is good enough. And 3 is, hey, I heard this new term. I want you to do this project to implement this thing and get done. And like none of those, like they all have different sets of steps that you have to follow. So it's more thinking about like one of the things that you've talked about is like how to navigate this. And it's very much thinking about that step-by-step process. Very first thing to me is learning and experimenting. I have this great past coworker who was showing some of the stuff he has been implementing and thinking about what questions he can ask of his system. And it was sort of like taking the data he already had. So metrics, logs, everything, aggregating it, writing a little code to visualize and be able to explore what was going on. And it helped them answer questions like, what caused this particular thing? That helped to instigate conversations about, wouldn't it be nice to answer these questions ad hoc rather than having to do all this manual work to process this? And that's like this really like one little step towards observability. Even if you're not getting the tools and purchasing new platforms, but you can take what you have now and start implementing things on top of it so you can start seeing into your systems. So we've got to wrap up, it looks like, because we're all running a little behind. So it has been so fantastic to talk to you, Ran. Thank you so much.
Thanks. It's been a pleasure, Jennifer. I really hope we had more time to discuss about it, but yeah.
Yeah, we totally have to spend more time talking about this offline.
Yeah, definitely.
Thank you so much, both. That was so great. I must say I am incredibly happy to see Azure Functions in Epsagon. That is fantastic. And hey, Ran, your t-shirt is absolutely the best. There were lots of comments and compliments. Yeah. That was really, really awesome. And Jennifer, thank you so much for sharing your insights and sharing all of this really important knowledge with everyone on the stream here. We're delighted to continue this conversation with all of you there on the chat. If you have any questions, head over to the office hours. As usual, the QR code is on the right-hand side of this slide. And then if you're interested in reading more about Epsagon, head over to their website. And to learn more about observability, there's tons of resources available at Microsoft Learn, and some of the resources that Jennifer and Ran will be sharing on their DevTube page. Thank you both. Have a wonderful rest of the day. Hope to catch up soon.